Yeah, welcome to online lecture 5. We focus on vectors and a few more data types in this class. So what are vectors? Vectors are a bus, or I can say it's a multiple bit lines. Scalar and vector with a perception of Verilog is single bit means we call single bit inputs means we call it as scalars. Let me write it here. Scalars are 1 bit. Vectors are n bits, means multiple bits. So that's the difference. So we are learning about vectors now. Okay. Nets or reg data types can be declared as vectors. That is multiple bit width. If bit width is not specified, the default is scalar. I said scalar means 1 bit. If nothing is specified, for example here, wire A. So wire A, you did not mention any something like vector or any data width. We call it as data width. 7 down to 0, 13 down to 1, 0 to 40, 40. All these are data widths. This one, this one, this one. We call it as data width. Bit width, I can say bit width. So if bit width is not mentioned, it's 1 bit by default. So wire A is a scalar variable which is of 1 bit capacity. Wire 7 down to 0 bus means bus is a variable or identifier of type wire or reg, of net, which has got 8 bits. Fine. So it is called 8-bit variable with a name bus. Here it is 0 down to 31 down to 0. So start from 31, 31 till 1 it is 31. 0 plus 0 means plus 1 more extra bit, 32 bits actually. We have three variables defined here: bus A, bus B, and bus C. So all these three variables are vectors. Bus A is a vector of 32 bits, bus B is a vector of 32 bits, bus C is also a vector of 32 bits. So three buses of 32 bit width. Reg clock. Clock is a register type data types variable and it has been a single bit, hence it is a scalar register with the name clock. 0 down to 40 is 41 bit width. Virtual underscore ADDR is a vector name. So it's a vector of 41 bits wide. That's the meaning. The process of writing the bit width is like this. Vectors can be declared at high number. It's a number you need to write. Higher number, I can say, lower number, or lower number or higher number. In this case, we read it as down to 31 down to 0. In this case, we read it as 0 to 40 or 0 up to 40 or 0 to 40. That's way. But the left number in the squared bracket is always the most significant bit of the vector. This is very important. The left number in the squared bracket is always the most significant bit of the vector. Left is this one. This is most significant bit. This is most significant bit. This is most significant bit. Okay, so you remember this. So writing, let me write something like wire 0 down to 1 B. So this B of 0, B of 1, this is MSB, this is LSB. Okay, similarly here if I take wire 1 down to 0 B1, so B1 of 1, B1 of 0, so this is MSB, this is LSB. This is how you need to remember. This is the order that you need to follow. So whatever you write on the left, that behaves as most significant bit. In the example shown above, so here is the example. Bit 0 is the most significant bit of vector virtual underscore ADDR. So here 0. This one is the most significant bit. Rest everywhere 7 is the most significant bit. 31 is the most significant bit there. Okay. Simple to understand. For the vector declaration shown above, it is possible to address bits or part of vector. Very important concept. Vector part select we call it as. For example, Think that we have declared a three bus architectures: bus A, bus B, bus 3. All these are 32-bit vectors. Bus A has been defined as, in previous slide, it has been defined as a 32-bit vector. Okay. So your bus A of 7 means we are picking up the seventh bit of a vector bus A. So this is 32-bit, like bus A of 32, 31, bus A of 30, bus A of 30, 29, bus A of 28, like that, bus A of 1, bus A of 0. So up till there, 32 bits will be there. In that, I'm specifying, I'm picking up bus A of 7th bit. So that bit I'm picking. That's the meaning of it. Okay. Bus 2 down to 0 means least significant bit of a vector bus. For example, bus was declared as this one, wire 7 down to 0 bus. This was the declaration. So it's nothing but it starts from bus 7, bus 6, continue, bus 3, bus 2, bus 1, bus 0. So total 7, 6, 5, 4, 3, 2, 1, 0. Total 8 bits. In that 8 bits, I'm just picking up 2 down to 0. So it is a 7 down to 0, right? 2 down to 0 means it will pick this one, and this one. Total 3 bits. 3 least significant bits, I can say. 3 least significant bits of vector bus is selected. Using bus 0 down to up to 2 is illegal because the significant bit should always be the left of the range specification. You should follow one order. If you are following high to low, follow high to low for picking up the particular part of the vector. Okay. Virtual underscore ADR01 is valid because it's been declared as 0 to 40. This was the way it was declared. So in that 0 to 1 means most significant 2 bits will be fetched. Virtual underscore ADR of 0, virtual underscore ADR of 1. So that particular 2 bits will be picked by this function or this variable. Okay, so I hope there are no doubts. So this is all about vectors. Now we'll move on to the few more data types. Integer, real and time register data types. All these are registers. All these are a kind of a register data type. There are three kinds: integer, real and time. We'll go in detail individually with all these three things. First we shall take register. Sorry, integer register. An integer is a general purpose register data type used for manipulating quantities. That's same as you have learned in your C language. Integer are declared by the keyword integer. The keyword uses integer itself. Okay, remember, this is a keyword, all in small case. Although it is possible to use reg as a general purpose variable, it is more convenient to declare an integer variable for the purpose of such counting. So you can also declare it as reg itself directly rather than using integer separately. If you declare integer, your work will be less because if you just type integer, it's as well as defining register of 32 bits. You know, the default width of integer is the host machine word size. It also depends on the host machine, which is implementation specific, but it is at least 32 bits. It's as good as, think that I'm defining something like this: integer I. Equivalent expression for writing this is register 31 down to 0 I. Both are same. This and this are same. Okay, it's your option is left to you. Integers declared as data type reg stores value as unsigned quantity. What is meaning of unsigned quantities? Unsigned quantities are, you don't have to bother about plus or minus. You don't have to bother about 2's complement or 1's complement. So it's just unsigned quantities. Whereas integer have a additional, function or additional feature, whereas integer stores values as signed quantities. That's the difference. So Here, of course, it is same, but integer have a capacity to store the values in terms of signed quantity. So that's one advantage. Here I have quoted one example. Integer counter. It's a counter is a variable of type integer. Initial counter is equal to -1, means I'm initializing this variable counter with -1. This is perfectly valid because this -1 is stored in the counter which is of type integer. That's perfectly valid. So that's the advantage of integer data type. Next comes real data type. So real data type is also falls under register data type. Real number constants and real register data types are declared with keyword real. Real is a keyword used. They can be specified in decimal notation. This is a decimal notation, or in scientific notation. Scientific notation is 3e6. Meaning is 3 into 10 raised to 6. It is 3 into 10 raised to 6. That's the meaning. Okay, 10 raised to 6. So if you write 3e6 by declaring real for initialization, it's called scientific notation. That's perfectly valid. To define a bigger numbers, we normally use real data type. Real numbers cannot have a range declaration. You cannot declare a range here. And the default value is 0. When real value is assigned to an integer, the real number is rounded off to the nearest integer. For example, 3.14, if I assign it to an integer, think that I define an integer. Here's an example. I'll quote the same example. Okay. Real delta. So delta is a variable of type real. Initialization, initial, begin, end. So two things I'm initializing. Delta initially I initialized it as 4e10. It's nothing but 4 into 10 raised to 10. That's a meaning. A big number. Okay, almost 40 billion I can say. So this is 2.13. So delta has been overwritten. So this is a sequential execution. First this will be executed. Delta will be assigned with, or else I can say it is been initialized with 4 into 10 raised to 10. Soon after that, the delta register of real type is been overwritten by or assigned by a new value called 2.13. What's the current value of delta now? Current value is 2.13. So I end it. So now delta is having the value 2.13. So integer I is a new declaration. Variable name is I of type integer. Initial, I'm initializing I with simply whatever the content delta is having. So delta is having 2.13, but I is an integer. Integer cannot have a rational numbers. So when you assign it, so here is a thing that the real number is rounded off to the nearest integer. So 2.13 will be rounded off to the nearest integer, that is 2. Okay, so very simple to understand. I hope there are no doubts in register or real type. So next is time. Verilog simulation is done with respect to simulation time. Very important. There is something called simulation time. So in your simulation, while explaining you the stimulus block writing, I explained you like #5, #10, #15 means after certain time units, we were changing the logics, and depending on that, the test bench waveform got generated. Test bench waveform, stimulus block writing, simulation, everything is dependent on the simulation time. So time is again a data type, which is a register data type. A special type of register data type is used in Verilog to store the simulation time. That is time. This is a special kind of register data type. What's it work? Its work is to store the simulation time. The keyword used is time. The width for the time register data type is again implementation specific, but it is at least a 64 bit, unlike integer. So integer is at least 32 bits, whereas time is at least 64 bits. The system function, this is a system task I can say. I'll take in detail about this in the coming slides. Dollar symbol, anything that starts with any keyword that starts with a dollar symbol is a system task or system function. Dollar symbol time is invoked at the current simulation time. So let me take an example. Time is a data type. Sim underscore time is a variable of type time. I'm initializing it with a dollar symbol time. What is this dollar symbol time means? It will fetch the current simulation time. What is the current simulation time? That will be assigned to this particular variable that we have just now initialized. Okay. Simulation time is measured in terms of simulation seconds. It is measured in terms of seconds. You can define it using tick time scale. That also we'll discuss later. Okay. So the unit is denoted by, yes, it stands for second. Okay. So remember one thing, the keyword starting with the dollar symbol is a system task. The keyword starting with tick, that is inverted comma, is a directive, I can say. Okay. It's a like you tick include, tick define, that is a things that we will be studying there in future. So it is one of that kind. Tick time, I can say, uh, tick time scale is a directive. Okay. So next is arrays. So what are arrays? So arrays are allowed in the Verilog for register type, integer type, time type, and vector register type, data type. Arrays are not allowed for real variables. Remember that arrays are not allowed for real variables. So if anything you declare with data type real, you cannot have a arrays for it because I have just now told that arrays real data type does not have a range. When it cannot be defined as a range, it cannot have arrays also. Arrays are accessed by array name followed by subscript. You can access the array members. Okay. Multi-dimensional arrays are not permitted in Verilog. These examples will explain you in a better way. Integer count 0 down 0 to 7. This is an array. See, it is quite different from what I write here. Integer 0 down to 0 up to 7 count. This is different than this. These two are not same. This is this is this is nothing but count with 8 bits. Count with 8 bits. This is count is an array of 8 variables. Okay, so an array of 8 count variables. Count of 0 is a first member of an array. Count of 1 is a second member of an array. Count of 7 is a eighth member of an array. Here it is not so. Here it is representing a bit. Count is a vector here. It's a vector here. Here it is not a vector. Here it is an array. If you write this, if you specify this width or a range after the variable, then it is an array. If you specify it before the variable, then it is a vector. Remember the difference. If you write in between the data type as well as the variable, then it is a vector. If you write at the end, then it is a array. Reg bool 31 down to 0 is register type. Bool is a variable. It's a 32 members. Array of 32 1-bit Boolean register variables. Why 1 bit? Because here if I want to mention some multiple bit, I should mention here. Here nothing is mentioned. By default it is 1 bit. By default it is 1 bit. So but it is 31 down to 0 members are there, means it is an array of 32 different Boolean register variables. Each 32 of each of that are 1 bit. 1 bit. Okay. So here again, time checkpoint 1 up to 100 is a 100 time checkpoint variables, each of 1 bit. It is starting from 1, so that's why 100. Here it is very important. Register type, port ID, you have vector also. So port ID is an array. How many members are there in this array? 8 members. 0 port ID 0, port ID 1, port ID 2, port ID 7. Total 8 port IDs you have. 8 members it has. Each member of port ID is of 5 bits. Okay, it's like this. Let me write it here. Port ID. I just write it as P. P of 0, P of 1, P of 7. You have 8 arrays. This is 8 members of an array. This is an array. Each of it, each of it is of 5 bits because 4 down to is 4, 3, 2, 1, 0, 5 bits. This is also 5 bits. 5 bits. Each of these are 5 bits. That's the meaning of it. Very important. You have vector also, you have array also. It is of 8 member array. Each member is of 5 bits. And I had said here, multi-dimensional arrays are not permitted in Verilog. So integer matrix 4 down to 0, 4 down to 0. So here in this way it is not possible because already you are telling it as it's an array. Array of array is not possible. So illegal declaration it is. Okay. Next, this is different section. Count of 5 means fifth element or fifth member of an array of count variable. Here I am having count of 0, count of 1, count of 2, count of 3, count of 4, count of 5, 6, 7. So count of 5, that particular array element or array member I am picking, I am referencing. Checkpoint of 100 means that particular array member I am highlighting. Port ID of 3 is this port ID of 3, somewhere here it will come. So that particular with 5 bits, it is of 5 bit. Okay, this is of 5 bit. This is of 5 bit value. So that particular thing I am referencing. Okay. Next, followed by. It is important to note not to confuse, I can say, not to confuse between arrays with net or register vectors. Vectors are different, arrays are different. For vectors, in between the data type and the variable, you'll be writing the specifying the width, whereas for arrays at the end. Vector is a single element that is n bit wide. On the other hand, arrays are always multiple elements that are 1 bit or n bits wide. Very important statement. Okay, so if you read this, you will understand it perfectly. Okay. So vector is always a single element of n bits wide, multiple bits wide, whereas array is a multiple member. It will be having multiple elements. Each element will be either 1 bit or n bit wide. How you declare it behaves according to your wish. So next is the concept of memories. Very important. Register, files, RAMs, ROMs. All these together we call it as memories. Memories are modeled in Verilog simply as an array of registers. You don't have separate, data types of called as memories, but whatever we have learned up till now, using that itself, we can design or devise the memories in the Verilog. You can model the memories in the Verilog. So whenever you want to save something, you need a memory. So when you want to save something and you want to process it in a Verilog code, memory comes into act. It's a very important one. Each element of an array is known as a word. You know, I said just now about arrays. Each member of it, we can call it as a word because it can have a capacity of storing 1 bit or n bit wide data. Each word can be 1 or more bits. It is important to differentiate between n 1 bit register, one n bit register. One n bit register is a vector, n 1 bit register is a array, I can say. A particular word in memory is obtained by using address as a memory array subscript. So you can use an array subscript to fetch a particular thing in a memory. For example, register is a data type. Mem 1 bit 0 1 bit means I did not specify anything here. By default, it is 1 bit. So it has got 0 to 1023 locations, I can say. Array member or array element, I call it as a location. I can depict it in this fashion: a table in your room or a stack like this, lot of racks. Here I'm declaring mem 1 bit. It is of 0 to 1023, means from 01 till 1023. Totally how many racks are here? You have 1024 racks. Each rack has capacity of storing how many books? I am having capacity to store only one book at a time. One bit word, that's the meaning. Okay, so this is mem 1 bit. Now similarly here, mem byte, same thing. So this is here. Now for this one, if I write it here, again location 0, 1 till 1023. How many locations, how many racks I am having now in my room? I have 1024 racks. Each rack has capacity to store how many books? It's 8 bit, right? I can store 8 books like this. 8 bits here, 8 bits here, 8 bits here, right? Totally in 1024 racks, I can place 8 books in each rack. So it is having huge capacity compared to this, right? So technically speaking, it's a memory with 1024 locations, wherein each location has a capacity to store 8 bits. Okay, so this is array element 1024 array elements or array members. Each element is of 8-bit vector. That's the meaning. Mem byte file 11 means initially it will fetch the particular location, then followed by particular bit. So 511 somewhere in between it will be there. The rack. This 511 rack will be somewhere here. This particular rack will be fetched. I'll be referencing this particular rack. In this, I have arranged 8 books, 8 bits, 8 books. I wanted to fetch fourth book. So 0, 1, 2, 3, third one. So I represent it as mem byte 511, 511th location, fourth book 0, 1, 2, 3. This is fourth book. So this is how I am referencing. Mem byte is a memory allocation wherein you have 1024 elements or locations. I am going to 511th location, 511th location. There, fourth bit. Fourth bit means 0, 1, 2, 3. So that particular thing I am referencing. This is also possible here. So that's all about memories. I hope it was interesting as well as understandable for you. Next is parameters. So parameter, Verilog allows constants to be defined in a module by keyword parameter. Parameter cannot be used as a variable. Parameter values for each module instance can be overridden individually at compile time. I'll just explain it with an example. This allows the module instances to be customized. For example, think that I have asked you to design a 4-bit triple carry adder. You design it, okay, and you call full adder 4 times because 4 full adders will be needed in order to design 4-bit triple carry adder. So 4 times you called. Now very next thing I say I need 6-bit triple carry adder. You need 2 more bits, 2 more full adders in addition. Now I ask you to design 8-bit full adder, 8-bit triple carry adder. You need 2 more extra. Again I say 16-bit full ripple carry adder, 256-bit ripple carry adder, like that. Every time you need to go on changing the code. What if I have a way to write a code wherein I define something like this, how many bits? I define this with generalized term like n, and whenever I change that n value to 4, the code should act as a 4-bit triple carry adder. If I change that to 6, automatically that code should change whole of things as if it is a 6-bit triple carry adder. If I change that n value to 256, it should behave as 256 triple carry adder. So that way I can do it using a parameter. I hope you got it. Okay, so parameter can be used as, parameter is a keyword, port underscore id is a variable which is equal to 5, means wherever port id comes in your code, everywhere it is replaced with 5. It will be treated as 5. Similarly, parameter underscore space cache underscore line underscore width is a parameter name, so which is equal to 256. Wherever you encounter cache underscore line underscore width in your code, it will be replaced by a constant 256. That's my meaning. That's the meaning. So 5 is like defines a constant port id 5. It's a constant 5. 5 is a value. Cache underscore line underscore width is a constant, and it's been defined as 256. Wherever in your code 250 cache underscore line underscore width comes, it will be replaced with 256. That's the meaning of parameter. Okay. So module definition may be written in terms of parameter. Hard coded number should be avoided because it will not be flexible if any changes to be done in your code. That's why we use something called parameter, which makes the hard coded numbers or codes into a flexible one. Parameters can be changed at module instantiation or by using define parameter, means deform. Dparam is a keyword. Dparam is a keyword, remember. What's it work? What is its work? Its work is you can define the parameter value anytime during the instantiation. Thus, use of parameter makes module definition flexible. So module behavior can be altered simply by changing the value of the parameter, so that wherever you have used that parameter name, everywhere that constant will be changed. Okay, that's the meaning of parameter. Next comes strings. So strings is an array of character that you have been learning in your since your first year, that is C language. So string can be stored in a register. So you can declare the strings using register itself. The width of the register variable must be large enough to hold the string. So it should be large enough, like each character needs something like 8 bits, so you should have large enough to store respective number of values, strings. Each character in the string takes up 8 bits, 1 byte. Each character in the string takes up 8 bits. Okay. If the width of the register is greater than the size of the string, Verilog fills bits to the left of the string with zeros. Remember, think that you have declared a register of a bigger capacity, but string is smaller. So I have a capacity to store 10 characters, but I am storing only SDM. SDM is a 3 byte character, a 3 byte string, three characters only. So the rest 7 will be filled with zeros. That's the meaning. If the register width is smaller than the string width, what should happen? Okay, Verilog truncates the left to most bits of the string. Remember. So think that I have declared a register of capacity of holding only 2 characters, and now I want to store SDM. So left to most bits, that is yes, will be gone. So it has got only storing 2 bits. I am storing SDM. So D will be ignored. That's the meaning. So it is always safe to declare a string that is higher, slightly wider than what is necessary. For example, register 8 into 18. This is possible. 8 into 18. Anyone here with good uh, in mathematics, like tables by heading? 18 into 8 will give some number down to 1. That's the meaning. Okay, so multiplication operator is used. By default it will take by itself. So okay, the meaning is 18 bit wide. 18 the wide it is 18, string is of 18 bytes wide, I can say. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12. So I have wider one, but I'm able to store only a few. How much it was? 1 2 3 4 5 6 7 8 9 10 11 12. So 12 character I need to store, but I am having a capacity of storing 8 bytes. That is perfectly okay. Okay, so string so not this one, this is a variable, sorry, this is a variable. I need to store this one. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So this has a capacity. String can be stored in a variable. Okay, so string value has a capacity of 18 bit wide, 18 byte wide, and you can definitely save this. So that's a string for you. So we shall throw some light on special characters that serve a purpose in displaying strings, such as new line, tabs, displaying arguments, values, etc. Special characters that can be displayed in the strings are, you know, only when they are preceded with escaped characters as shown in the table. So if you use escaped character, then that particular string will not be displayed, but it will display something else. For example, escaped character, if you use backward slash n, it is nothing but new line. Backward slash t, is nothing but tab. Double percentage means it will display single percentage. Double backward slash displays single backward slash. Backward slash in inverted double quote will display inverted double quote. Backward slash 000 will display a character written in octal digit 1 2 3, from starting from 1 or 2 3 octal digits. So this is how the escaped characters or special characters are displayed. So next comes system task and compiler directives. I was not getting this word into my mind. So it is compiler directive. System task. I'll just start it. We'll continue in the next class. Okay. Task always start with dollar symbol. Compiler directive starts with tick, inverted single quote. Okay. So system task and compiler directive. Already we have come across system tasks like dollar symbol display, dollar symbol monitor, dollar symbol time and all. Those all are system tasks. Compiler directives are tick, tick, define, tick, include. All these are time directives. Okay, so we will learn those in detail. System tasks separately and compile separately. Okay, so we will continue these system task and compiler directives in next class. Okay, so if you have any doubts, I'll take that now. I'll clear our doubts for the next 5 minutes. So please come up in the chat box if you have any doubts. Yes, anybody has any doubts?
Yes, sir.
Mr. Malekar, do you have any doubts?
No, sir.
No. Okay. I think I you have unintentionally unmuted. So any of you, if you have any doubt, please come up in the chat box.